Your V-twin isn't dying from mileage, it's dying from 13 habits that feel completely normal while they silently score bearings, glaze cylinders, and cook oil into sludge. We're counting down from number 13 to number 1, and the habit at the top of this list is something most riders do every single time they start the bike. Number 13. The throttle blip. You've seen it 1,000 times. Rider pulls up, kills the engine, but right before shutdown gives the throttle 2 or 3 quick blips. Sounds good. Feels like motorcycle ritual. The problem is what happens inside the cylinders during those final revs. When you blip the throttle with the engine about to stop, you're pulling additional fuel into the combustion chambers while the piston rings are making their last few passes. That fuel washes down the cylinder walls, stripping the oil film that's supposed to protect the metal surfaces overnight. The engine stops, the bike sits, and now you've got bare cylinder walls with no oil barrier between the rings and the bore. Next morning, you hit the starter. The piston makes its first stroke against metal that's been sitting unprotected for 8, 12, maybe 72 hours. That first cold rotation happens before the oil pump can deliver fresh lubrication to the upper cylinder. Ring wear, measured in microns, invisible to you, undetectable without specialized equipment, accumulates with every blip and park cycle. The old-timers who started this habit were clearing carburetors on bikes that sat for weeks. Your fuel-injected V-twin doesn't need it. The correction is straightforward. Let the engine idle for 15 to 20 seconds after your last ride input, then hit the kill switch cleanly. No farewell blips. Your cylinder walls will still have oil on them when you come back tomorrow. Number 12. The viscosity collapse during cold starts. 20W50 oil behaves like 2 completely different fluids depending on temperature. At 50 degrees Fahrenheit, that oil sits in your cases with a viscosity somewhere around 500 centipoise. Thick, resistant to flow, slow to move through galleries and reach bearings. At 180 degrees, that same oil thins to operating viscosity and flows freely to every critical surface. The first 90 seconds after a cold start is where bearing damage accumulates invisibly. Your oil pump is working, but the fluid it's pushing hasn't reached temperature. It's moving through passages like cold honey while your connecting rod bearings, your cam bearings, your wrist pins are all asking for lubrication that's arriving late and arriving thick. The rider who fires up the bike waits 30 seconds and hammers onto the freeway at 4,000 RPM thinks he was patient. He wasn't. His rod bearings are experiencing metal-to-metal loading while that 50-degree oil crawls toward operating temperature. The damage doesn't announce itself. No knock, no noise, no warning light, just microscopic scoring that accumulates over hundreds of cold starts until bearing clearances open up, and suddenly you've got a 4-figure rebuild on your hands. The correction is simple: 45 seconds of idle minimum, then gentle riding, not freeway speed, not highway RPM, until oil temperature crosses 180 degrees. Your gauge tells you when it's safe to ride hard. Until then, the bearings are on their own. Number 11. The 6th gear lug. It feels smooth. It sounds quiet. Cruising at 1900 RPM in top gear, the engine barely working, the tachometer needle resting low. Most riders think they're being kind to the motor. What's actually happening is mechanical abuse disguised as gentle riding. Below 2000 RPM under throttle load, your V-twin enters a lugging condition where combustion pressure spikes dramatically while oil pump output drops. The engine is being asked to produce torque it can deliver, but at RPM too low to maintain stable oil pressure. Every lug cycle sends shock loads through the drivetrain, and the component that absorbs the worst of it is the cam chain tensioner. Factory torque specifications assume the engine operates within a designed RPM window. When you ask for acceleration below that window, the instantaneous loading exceeds what the tensioner is designed to handle. Over thousands of miles, the tensioner wears prematurely, cam chain slack develops, and valve timing drifts out of specification. The rider who eventually hears the telltale chain rattle blames mileage, but his bike has 60,000 miles, while his buddy's identical bike has 90,000 with no tensioner issues. The difference isn't luck, it's shifting habits. The correction is simple: keep the tachometer above 2200 RPM when applying throttle. If the engine sounds labored, you're in too high a gear. Downshift. Your cam timing will thank you for the next 50,000 miles. Number 10. The ethanol clock. E10 gasoline contains 10% ethanol by volume. That ethanol is hygroscopic. It actively pulls moisture from the air inside your fuel tank. This moisture absorption begins the moment you fill up and continues every time temperature changes cause the tank to breathe. After roughly 90 days of storage, ethanol-blended fuel reaches phase separation, the point where the ethanol-water mixture drops out of suspension and settles to the bottom of your tank. Your fuel petcock or fuel pump pickup sits at the lowest point. Guess what it's drinking first? The chemistry gets worse. Ethanol attacks rubber compounds used in fuel lines, carburetor diaphragms, and injector O-rings. Harley service bulletins document injector body corrosion beginning as early as 60 days in bikes that sit with E10 fuel and no stabilizer. The corrosion starts inside the injector, invisible until flow rates drop and your ECM starts throwing lean codes. Carburetor bikes fare worse. The accelerator pump diaphragm swells, hardens, and cracks. The rider who stores his bike for winter without fuel stabilizer and returns in spring to a bike that won't idle has just fed his fuel system 4 months of corrosive soup. The correction is straightforward. Ethanol-free fuel when available, fuel stabilizer added at every fill-up during storage season, and never let fuel sit longer than 30 days without running the engine. Number 9. The heat soak. The ride is over. You pull into the garage, hit the kill switch, swing your leg over, and head inside. But your engine doesn't know the ride ended. At 215 degrees oil temperature, shutdown triggers a phenomenon called heat soak. With no circulation, no airflow, and no cooling, residual heat migrates from the heads and cylinders into surrounding components. The fuel sitting in your injector rail or carburetor bowls absorbs that heat and begins to vaporize. Fuel vapor in the rail creates air pockets that cause hard starting and lean stumbles on your next cold start. Worse, your intake gaskets are sitting between hot heads and a manifold that's cooling at a different rate. The temperature differential stresses the gasket material, not enough to fail today, but enough to begin the microcracking that shows up as a vacuum leak 3 months later. The rider who parks hot every time and never connects his intake leak to his shutdown habits will chase that lean condition for hours before finding cracked gaskets. The correction requires patience. If you've been riding hard and oil temp is above 200 degrees, give the engine 90 seconds to 2 minutes of idle before shutdown. Let the oil circulate and carry heat away from the heads. Let temperatures stabilize. The damage that happens after you walk away is real and completely preventable. Number 8. The primary chain. Stretch you cannot hear. Harley specifies a 1,000-mile inspection interval for primary chain tension on new bikes and after any adjustment. Most riders check it once, adjust it once, and forget it exists. The problem is that primary chains stretch at a predictable rate under load, roughly 1/32 of an inch per 1,000 miles during break-in, slower after that but never stopping. When chain slack accumulates beyond factory specification, the compensator sprocket absorbs impact loads it was never designed to handle. That compensator is a spring-loaded shock absorber for your drivetrain. With a loose primary chain, it's doing double duty on every throttle input and every gear engagement. By the time you hear the characteristic compensator knock, that metallic clunk on deceleration, the sprocket faces are already damaged. The wear pattern is irreversible. Riders who blame compensator failures on design flaws often created the failure themselves by ignoring primary chain tension for 20,000 miles. The chain stretched, the slack transferred impact to the compensator, and the compensator wore itself out, absorbing abuse that proper adjustment would have prevented. The correction is simple but requires discipline. Check primary chain deflection at every oil change interval. 1/2 inch to 5/8 of an inch of deflection at the midpoint between sprockets is the typical specification, but verify against your service manual. 10 minutes of inspection prevents a $500 compensator replacement. Number 7. The 3-pound feat that cooks your spark plug. We're past the halfway point, and the habits ahead are the ones most riders never suspect. This one involves a tool you've used 100 times, a spark plug wrench. Factory torque specification for most Harley spark plugs is 11 to 18 pound-feet, depending on the engine. Exceed that by 3 pound-feet, an amount you'd never notice by hand, and you've crushed the sealing washer flat. That washer isn't just for sealing combustion pressure, it's a thermal break between the plug and the head. When you over-torque and crush the washer, you create a direct metal-to-metal heat pathway from the combustion chamber into the plug body. The plug runs hotter than designed. The electrode tip reaches temperatures that cause pre-ignition, spontaneous combustion before the spark event. Pre-ignition hammers your pistons with pressure spikes the engine wasn't built to handle. Service bulletins document cylinder head temperatures rising 15 to 20 degrees from over-torqued plugs alone. The rider who hand tightens his plugs until they feel snug is likely 3 to 5 pound-feet over specification on at least one cylinder. The correction requires a torque wrench, no exceptions, 12 pound-feet on a crush washer plug, hand tight plus 1/16th turn on a tapered seat plug. Your shop manual lists the exact specification. Use it. Number 6. The lifter bleed down that grinds your cam lobes. Hydraulic lifters in your V-twin contain oil under pressure. That oil maintains zero valve lash and keeps the entire valve train geometry in specification. When your bike sits for extended periods without engine rotation, 4 weeks, 6 weeks, longer, that pressurized oil slowly bleeds past the internal check valve and drains back to the cases. The lifter collapses. Now your valve train has clearance it shouldn't have. On the next cold start, before oil pressure rebuilds in the lifter body, the rocker arm is hammering down on a collapsed lifter while the cam lobe pushes up from below. You hear it as clatter, that startup rattle that goes away after 30 seconds. What you're hearing is actual contact between the cam lobe and the lifter base, metal on metal with no oil cushion. The cam lobe surface hardening is only a few thousandths of an inch deep. Once you wear through it, the soft metal underneath erodes rapidly. Riders who store their bikes for winter and start them once in spring with that characteristic cold clatter are grinding their camshaft every time. The correction requires either regular engine rotation, starting the bike every 2 weeks and letting it reach oil pressure, or accepting that extended storage demands a proper startup protocol, prime the oil system if possible, and keep RPM below 1500 until the lifter clatter stops completely. Number 5. The air filter restriction triggering fuel wash. Your ECM monitors airflow through the MAP sensor and adjusts fuel delivery to maintain target air-fuel ratios. When your air filter reaches 30% restriction, a level that feels like normal operation to the rider, the ECM detects reduced airflow and compensates by enriching the mixture. Richer mixture means more fuel per combustion event. That additional fuel doesn't all burn. Some of it washes past the piston rings and dilutes your engine oil. Oil analysis from bikes with restricted filters shows fuel dilution percentages climbing from the normal 1 to 2% range into 4, 5, even 7% territory. Fuel in your oil reduces viscosity, compromises film strength, and accelerates ring wear as the contaminated oil fails to maintain the barrier between ring and cylinder wall. The wear pattern shows up in oil analysis long before the rider notices any performance change. By the time the bike feels down on power, the cylinder walls have already taken damage. The correction is straightforward. Replace paper air filters at the manufacturer's specified interval or earlier in dusty conditions. Cleanable filters need service every 5,000 miles. A $30 filter prevents a $3,000 top-end rebuild. Number 4. The transmission oil contamination you cannot see. Harley V-twins use separate oil for the transmission and primary, and that transmission fluid breaks down under sheer stress from gear engagement. Factory change interval is typically 5,000 miles, but viscosity breakdown begins well before that threshold. By 7,000 miles, transmission oil has lost measurable film strength. The synchronizers and gear faces still function, but the clutch plates sitting in that degraded fluid are beginning to glaze. Clutch plate glazing is a surface hardening that reduces friction coefficient. The plates slip under load before they should. The critical detail: glazing begins roughly 2,000 miles before you feel clutch slip. By the time the clutch slips on a hard launch or a highway pull, the plates are already damaged beyond simple adjustment. The rider who stretched his transmission oil changed to 8,000 miles and now has clutch slip didn't damage his clutch 8,000 miles in. He damaged it at 6,000 miles and rode 2,000 more while the glazing worsened. The correction is discipline. Change transmission and primary fluid at 5,000 miles. Every time, no exceptions. The fluid costs $40. The clutch pack costs $400. That math only works out one way. Number 3. The voltage drop cascade that strands you. 3 items remain, and each one escalates the damage pathway significantly. Battery terminal oxidation is invisible to the eye in its early stages, a thin film of corrosion that increases resistance without any visible buildup. That resistance creates voltage drop between your battery and your electrical system. Your stator responds by working harder to compensate, increasing current output to maintain system voltage. Stator windings are cooled by engine oil and designed for a specific current load. When oxidation forces the stator to output higher amperage continuously, winding temperature rises beyond design parameters. The insulation on those windings degrades under heat. Eventually, a winding shorts, stator output drops, and your charging system fails. The rider stranded 50 miles from home with a dead battery and a fried stator rarely connects the failure to corroded terminals he never noticed. The diagnostic chain is clear. Oxidation caused resistance. Resistance demanded higher stator current. Higher current caused winding failure. The correction takes 5 minutes. Clean battery terminals with a wire brush or terminal cleaner every oil change. Apply dielectric grease to prevent new oxidation and verify charging system voltage at the battery with a multimeter. 14.2 to 14.6 volts at 2000 RPM means your system is healthy. Below that, start troubleshooting before the stator cooks itself. Number 2. The single cold acceleration that scores your cylinders. We're almost at number 1, and this habit is one most riders commit without knowing it. Just once is enough. Oil film on cylinder walls requires 30 to 45 seconds of oil circulation to establish full coverage after a cold start. During those first moments, the film is thin, incomplete, and vulnerable. Aggressive throttle application, even once, forces piston rings outward against cylinder walls that don't have adequate oil protection. Tribology data from engine teardowns shows a specific scuffing pattern that occurs during cold engine acceleration. Vertical scoring marks on the thrust side of the cylinder, concentrated in the upper third of the bore, where film coverage is weakest at cold startup. This scoring increases oil consumption permanently. The rider doesn't feel the scuff occur. The bike doesn't stumble or knock. But 6 months later, he's adding a half quart between oil changes and doesn't know why. The scuffing happened in a single 3-second event. One aggressive throttle snap on a cold engine and created damage that will burn oil for the remaining life of the motor. The correction is absolute. No hard acceleration until oil temperature reaches 180 degrees. If you're in a hurry, leave earlier. Your cylinder walls cannot be unscuffed once the damage occurs. Number 1. The idle that glazes your cylinders from the inside. This is the habit that destroys more V-twins than any other on this list, and it's the one most riders believe is protecting their engine. Extended idling, letting the bike warm up in the driveway for 5, 10, 15 minutes, sitting at rally staging areas with the engine rumbling, idling through slow traffic for 20 minutes because you don't want to shut down and restart. Every minute of idle beyond 60 seconds on an air-cooled V-twin causes damage that accumulates invisibly until it's irreversible. The combustion chemistry at idle is fundamentally different from loaded operation. Combustion temperatures are lower, flame propagation is incomplete, and unburned hydrocarbons make it past the rings and into the crankcase. Fuel dilution at idle occurs at roughly 3 times the rate of loaded operation, but the deeper damage is happening on the cylinder walls themselves. Low combustion temperature fails to fully expand the piston rings against the bore. The rings flutter instead of seating, blow-by increases, and the cylinder wall surface begins to glaze, a polishing effect that destroys the crosshatch pattern machined into the bore to retain oil. Once that crosshatch is glazed over, the cylinder can no longer hold an oil film properly. Compression drops, oil consumption rises, the engine feels tired, down on power, burning more fuel. A compression test reveals the truth. Cylinders that should read 150 psi are showing 120 or less. The rider who babied his engine with long warm-ups and gentle idling glazed his cylinders into early retirement. The correction contradicts what feels right. 45 seconds of idle maximum after cold start, then ride gently. Keep the engine loaded and the RPM above 2,000. An air-cooled V-twin needs airflow to survive. Sitting still is not resting. Sitting still is slow-motion engine failure. Every habit on this list shares one trait. It feels harmless while the damage accumulates out of sight. Your V-twin doesn't need luck to cross 100,000 miles. It needs you to stop doing the things that quietly destroy it. Subscribe for more V-twin maintenance breakdowns that keep your engine running long after the warranty expires.